Let's review some exponent rules. We're going to look at quite a few exponent rules here. We want to be really good at recognizing them when they're isolated so that we can put them all together and simplify expressions with exponents. Product rule. When we're multiplying two bases together, we can add their exponents. So let's look at this example here. X to the m power times x to the n. Well, the base is the x, and we're multiplying them together so we can add their exponents, m plus n. Let's look at this with some examples. X to the third times x to the eighth. Well, I'm multiplying, the bases are the same, they're both x's, so x to the 3 plus 8, x to the 11th. The next one, 2 to the fourth times 2 to the second. Well, hold on, just because there's numbers now, my base is still 2, so all I have to do is add the exponents. So 2 to the 4 plus 2 is 2 to the 6th. We don't have to multiply those bases and get 4 to the 6th. That wouldn't make sense. Last one, x squared times y times x to the third times y to the fourth. Okay, things with the same bases, I can add their exponents. So let's look. I've got x squared and I've got x to the third. I'm just multiplying here, so same base, add their exponents. 2 plus 3 is 5, so I'm gonna have x to the 5th. Okay, now for the y's. We've got y, and then I put to the 1 power on it, times y to the 4th power. Well, I'm multiplying, so I add their exponents, so y to the 5th power.
Quotient rule. We look at it somewhat similarly. They have to have the same base, but then we subtract the exponents. So x to the m divided by x to the n would be x to the m minus n. Let's practice. A, x to the 5th divided by x squared. We could also look at this a little bit more explicitly. Like, why does this work? Because x to the 5th is x times x times x times x times x divided by x squared, so divided by x times x. We can divide out 2 of those x's, and we're left with x cubed. So that's kind of why this property works, but let's keep in mind that it's not math magic, right? We do subtract 5 minus 2 and get 3. Next, look at B. 3 to the 5th divided by 3 to the 3rd. What's our answer? Yep, 3 squared. Were you tempted to say like 1 squared or 9 squared? Remember, just keep the base. You try example C. xy squared. Zero exponent rule. Anytime we raise anything to the 0 power, it equals 1. Well, except if we're raising 0 to the 0. That's a whole different story. Let's not worry about that. So if I have 1 million raised to the 0 power, it equals 1. So example A, y to the 0 equals 1. 6 to the 0, does it equal 6? Does it equal 0? No, it equals 1. All right, what about that last one? I got a bunch of stuff in parentheses, but the whole thing in parentheses is being raised to the 0 power. What does it equal? 1. Yes. Now, why does this work? Let's take a real quick look at this. What if I had x to the 5th divided by x to the 5th? Well, we know that that would be x times x times x. We know that equals 1. But what if we use that quotient property? The quotient property says x to the m divided by x to the n is x to the m minus n. Well, then x to the 5 minus 5 is x to the 0. It equals 1 because x to the 5th divided by x to the 5th would equal 1. So that is the 0 exponent rule. What about our power rule? A power raised to a power. You really have to highlight this in your head because now we're not talking about the product rule where we have the base times the same base raised to an exponent, the same base raised to an exponent, and we add exponents. No, now we have an expression raised to another exponent. So x raised to the m raised to the n, I multiply the exponents in that situation. Try and keep in mind close by multiply. That's way different than product rule. So x to the x cubed, that's now been squared, close by multiply, x to the 3 times 2, x to the 6th. Whew, I think you got it. Finish the other two. Once again, probably the only thing I would have been worried about is did you just keep that base on B, the base is 3, don't change the base, and then multiply those exponents. Why? Close by multiply.
Speaking of close by multiply, let's look at expanded power rule. Expanded power rule just says if we have something in parentheses all to a power, we apply that power to everything in that parentheses. So like xy in parentheses all to the m power is x to the m power y to the m power, or x divided by y all to the m power is x to the m power divided by y to the m power. So let's test this. 2a all to the third power is just 2 to the third power, a to the third power. No big deal. 2 to the third power we know is 8, so I'm going to go ahead and write it as 8 times a to the third power. Okay, 6x cubed all to the second power. All right, so it's all to the second power, so I'm going to use expanded power rule first. 6 to the second power, x to the third to the second power. Close by, multiply. So we got x to the 6th power, 3 times 2, not 5th power. So that's 36x to the 6th. Let's look at C. X squared divided by y all to the 4th power. Okay, here we go. X to the 2nd to the 4th power. Close by, multiply. X to the 8th divided by y to the 4th. No big deal. Try that last one. Check your answer. 8x to the 3rd divided by 27y to the 6th. Be really careful. Close by, multiply. Negative exponents. It's always easier to work with positive exponents. So when we have negative exponents come up, we want to try to force them to be positive. And we can do that by moving their placement in the fraction. If I have x to the negative m, I can rewrite it as 1 over x to the m. So I take that base and its negative exponent and move it to the denominator, and that forces that exponent to become positive. So if I have 1 divided by x to the negative m, to force that exponent to be positive, I can move it now to the numerator with its base. So x to the m. If I have x divided by y all to the negative n power, I can expand that into x to the negative n power divided by y to the negative n power. Well, they both have negative exponents, so if I move their placement, I get y to the n divided by x to the n. So really, all that happened there was I ended up flipping the fraction. So I could write it as y divided by x all to the positive n power. Let's practice using these negative exponents. X to the negative 3. If we want to rewrite this so we're working with positive exponents, I just rewrite it as 1 over x to the 3. 4 to the negative 2. I know it's super tempting to think you can do like 4 to the 2 power and get 16 and be like, oh, it's just negative 16. False. That is not a true statement. 4 to the negative 2, we can't work with that negative exponent. We need to make it positive. So 1 over 4 squared, well, now I can do 4 squared is 16. So 4 to the negative 2 is really 1 divided by 16. Now we look at C, and it is so tempting to do some wrong math here, so be so careful. We have negative 4, x to the 5th, y to the negative 2. What do you think you're going to fix? It is not the negative 4. What's the power on that negative 4? Negative 4 to the 1 power. It has a positive exponent, so we don't need to move the negative 4 anywhere. He's just going to chill out with the x to the 5th, because the x to the 5th also has a positive exponent. The only thing that's going to move is that y to the negative 2. Going to move to the denominator, so it can be y to the positive 2. No big deal. All right, then we look at D, x squared divided by y, all to that negative 3. Let me expand that. Close by, multiply. So x to the negative 6, that negative 3 exponent's also going to go to the y, so y to the negative 3. All right, I have some unhappy exponents there. We're going to go ahead and move them, make them positive. So y to the 3rd is going to be in the numerator, and x to the positive 6 is going to be in the denominator.
Example E. Okay, now we see where we have multiple properties coming into play. And the thing about these is you can do them multiple ways, but with experience, you figure out like maybe the easier way. So as I look at example E, I'm going to go ahead and multiply my coefficients. So 3 times negative 2 get negative 6. Then I look at that x to the negative 2 and I have another x. Well, should I move that x to the negative 2 and make it positive? I could, but I could also go ahead and combine using the product rule and then take care of it later. So just know that there is more than one way to do this, and it's okay so long as we get the right answer. So x to the negative 2 times x to the positive 1, negative 2 plus 1 is negative 1. So now I have the coefficient negative 6 and then x to the negative 1. Last, look at our y values. Our y values, we have y to the positive 1 and y to the negative 3. It's the product rule currently, so I'm going to do 1 plus negative 3 and get negative 2. So currently I have negative 6, x to the negative 1, y to the negative 2. Then I want to rewrite with positive exponents. Remember, negative 6 is a coefficient. It does not move. But that x and the y both have negative exponents, so they have permission to move. I like to do a little circle, anything that has a negative exponent, and say permission to move. And in this case, they're in the numerator, so I need to move them down. So my final answer for this problem should be negative 6 divided by xy squared. Looking at example F. All right, I have 4 different variables. Which ones have negative exponents on them? Those are the ones with permission to move. I like to circle and draw an arrow. B cubed did not have permission to move, but all of the other variables did. Did you get the correct answer? Last, let's look at G. Oh my. All right, close by multiply. We're going to bring in that -2 power, but this is really interesting because my coefficient is -2 also. So when I'm bringing it into that -2, I actually need to keep the -2 in parentheses because the -2 power will apply to that -2 coefficient. So the interesting thing is when I multiplied in the -2 exponent to the other pieces of that, we ended up changing the y from a negative exponent to a positive exponent because -4 times -2 is +8. So this is one reason why it might be nice to go ahead and do close by multiply, then move things. Which things have permission to move? Well, the -2 to the -2 exponent. It has permission to move because of the -2 exponent, not because the base is -2. And the x to the -4 has permission to move. So I'm going to move those to the denominator, and then I will clean up that -2 to the +2 power. Y to the 8th divided by 4x to the 4th. Notice that once I had the -2 in parentheses, brought down to the denominator to the +2 power, -2 times -2 is +4. You can see that the quotient is written out at the bottom that we've already talked about. Just because something is negative doesn't mean that it moves. It only moves if the exponent is negative. Last, let's remember what I did in example G, right? The -2 was in parentheses, so then that meant -2 times -2 when I squared it. If it's not in parentheses, then just the 2 would have been squared. We see this example with -3 written. So -3 in parentheses, quantity squared means -3 times -3, +9. But in the next portion, we just see -3 squared. I like to really emphasize this to try and get it to stick in your mind by saying it's really a -1 times a 3 squared. So -1 times 3 squared is 9. -1 times 9 is -9. Very important, the placement of parentheses.
Now that we reviewed all these isolated exponent rules, let's try problems where we might have to use more than one at once. So looking at this first one, 13, what do you think I'm going to try first? I'm going to use expanded power property first. I'm going to go ahead and expand this, so 2 squared c squared d to the 6 or 8. Close by multiply, d to the 8th, and then c to the 5th, d to the 5th. Well, am I done there now that I've expanded it all out? No, I have things with the same base being multiplied, so I need to add their exponents. So c to the 7th and d to the 13th. 2 squared, I know is 4, so I just write 4. Now looking at this next one, okay, well, I have a big set of parentheses all to the 4th power, so maybe I should expand? I mean, nothing's wrong to do first here, but if I start expanding, do you guys see what's gonna happen? I'm gonna get a 5 to the 4th power and a 20 to the 4th power. Ooh, I don't know what those numbers are. So what if I go ahead and simplify the inside of the parentheses before I expand this out? So 5 divided by 20 is just 1/4. X to the 3rd divided by x, well, if I put a little 1 power on that x, 3 minus 1, because I'm dividing, right, would be 2, so x squared. And then y to the 1 power again, divided by y to the 5th, 1 minus 5 would be -4. Well, I don't really want to write it as y to the -4, so I could just move that to the denominator and write y to the 4th. So I've got x squared divided by 4, because of that 1/4 from 5 divided by 20, y to the 4th. All of that is being taken to that 4th power, so I can't forget that part. Now I can go ahead and expand since I've simplified that inside. So close by multiply, it's going to be x to the 8th divided by 4 to the 4th and y to the 4 times 4, 16.
37. Okay, these can be exciting when you get them right, but there's a lot of stuff going on here. So I look in that parentheses and I go, is there anything I can simplify, just like Miss Ryan was talking about? I want to probably simplify before I worry about that -4 exponent. There's so many things we could do, because the -4 exponent, I could flip the whole fraction right now. I could expand and bring it in and then worry about each little thing separately. But I think I'm going to go ahead and simplify inside parentheses and then make a decision after that. So c to the 0, anything to the 0 power is what? 1, not 0, right? C to the 0 is 1. So basically I've taken care of that. Then I have -7 divided by 3. Well, I can't reduce that, but I have a squared over a cubed. Now, rather than doing straight subtraction here, 2 minus 3, -1, where does it go? I like to think of it just as division. So a squared, how many do I have on top? 2. A cubed, how many do I have on bottom? 3. How many would divide out if I have 2 a's on top and 3 a's on bottom? Well, 2 of them would divide out, leaving how many? 1. Where? Top or bottom? On the bottom, because that's where most of them were. Same thing when I look at b cubed over b to the 4th. How many b's on top? How many b's on bottom? How many divide out? 1, 2, 3. How many are left? Top or bottom? Wherever most of them were, and they were on the bottom. Okay, now we have a decision. Now I think if you're not sure about how to do things, the best thing to do would do the expand property and bring that -4 power into everything. When you do that, everything will have a negative exponent on it and you will end up moving everything. Everything's going to have permission to move. So we alluded to it earlier in the notes, and you just kind of have to know what you're comfortable with. I'm going to go ahead and show this where I know that -4 on the outside, I can flip the fraction and it will become a +4 on the outside. If you're not comfortable with that, please don't do it. Make sure that we end up with the same answer. Once we flipped the fraction, then we had a +4 exponent, and all I had to do was close by multiply. The only tricky thing here is your -7 in parentheses still? It's very important because it's being raised to a +4. So if I did want to go ahead and multiply this out, -7, -7, -7, -7, I'll end up with a positive answer in that denominator. Without the parentheses, it would be a different answer.